Today we're going to continue to look at Learning Target 11A and focus on finding and using theoretical and experimental probabilities. So today we're going to look at how can we use these probabilities to help us make a prediction. So let's say that you roll a number cube 30 times. How many times would you expect to roll a 3? Okay, well we know that if you actually roll the number cube 30 times, it may or may not match up the results with what you would have expected based on the theoretical probability. But since we're making a prediction before we actually do the experiment, we're going to use the theoretical probability to help us with making that prediction of how many times we would expect a 3. So first thing I want you to think about is, what is the theoretical probability? Well, we know that a number cube has 6 sides. We know only one of them has a 3 on it, and so our probability of rolling a 3 is 1 out of 6. Now this would be a situation where we can use our proportional reasoning. If we know that 1 out of 6 sides on the dice has a 3 on it, then we would expect that same ratio to hold true when we do a bunch of trials. And so if we set up a proportion, so remember blank equals blank, I can put my theoretical probability on one side, so 1 over 6, and on the other side I can try to find out how many would that be out of 30 total. Okay, so solving a proportion, remember you can cross multiply or you can look for either a vertical or a horizontal relationship. And so in this case, I know that if I multiply 6 times 5, that's going to give me 30. And so I can do the same thing to the top. And so 1 times 5 is going to give me 5. So I would expect to roll a 3 about 5 times out of 30 rolls. Okay, so let's try another one. You spin the spinner below 44 times. How many times would you expect the spinner to land on yellow? Okay, so first thing I want you to think about is, what is the probability of spinning that spinner and landing on yellow? So what is that theoretical probability? Okay, hopefully you said that theoretical probability of landing on yellow was 1 out of 4. There is one section that is yellow out of 4 sections that are all equally sized. So our probability is 1 out of 4. So then again, we can use proportional reasoning, saying if we expect to get yellow 1 out of 4 times, then how many times would we expect to have it out of 44 times? And so go ahead and solve that proportion. All right, and hopefully you came up with x is equal to 11. So we would expect to spin yellow about 11 times out of 44 spins. All right, and let's do one more here. You flip a coin 13 times. How many times would you expect for the coin to land on tails? Okay, so first thing I want you to do is think about, what is your theoretical probability of flipping a coin and getting tails? All right, I'm hoping everybody said 1 out of 2 or 1/2. Okay, and so using that knowledge, how many times would you expect to get tails out of 13 times? Okay, so hopefully you set up a proportion. 1 out of 2 has to equal x out of 13, and so we would expect to flip tails about 6.5 times out of 13 trials. Okay, now even though when you actually flip a coin 13 times, you can't actually get 6.5 times landing on tails, that's what we expect. And it's okay for it to be a decimal. It's okay for it to be something that isn't actually like a number that we could get in real life. It's kind of like when you have the mean of a data set. Sometimes the mean is not an actual number that's in your data set, and that's okay. It's used to sort of show us, you know, what should happen in theory. And so again, it's okay to leave it as a decimal. Okay, so the next thing we want to focus on is how to determine if a game is fair or not. And so in mathematics, we define a fair game as being one where each player has an equally likely chance of winning. Okay? And so nobody is at an advantage over anyone else. It's equally likely for any person to win. And so an unfair game then would be a game where it's not equally likely for each person to win. All right, so you and a friend are playing a game with the spinner below. If you spin an even number, you get a point. If your friend spins a prime number, they get a point. And the person with the most points at the end of 10 turns wins. Okay, so first thing we want to look at are, what are the possible outcomes that are going to get you a point, and what are the possible outcomes that would get your friend a point? And so for you, if you spin an even number, you get a point. So looking at our spinner here, numbers numbered 1 through 8, the even numbers would be 2, 4, 6, and 8. Okay, so that's 4 favorable outcomes, right, the ones that you want, out of a total of 8 outcomes. So 4 out of 8 would mean that the probability of you landing on an even section and therefore getting a point would be 1/2. Now your friend gets a point anytime they spin a prime number. So looking at our prime numbers here, remember our prime number is one where its only factors are 1 in itself. Now technically 1 is not considered prime. 2 is prime, its only factors are 1 in itself. 3 is prime. 4 is not because 4 is divisible by 2. 5 is prime. 6 is not because it's divisible by both 2 and 3. 7 would be prime, and 8 is not. So of those numbers, we said 2, 3, 5, and 7 are prime. So again, that's 4 favorable outcomes out of a total of 8 possibilities. And so 4 out of 8 is again a probability of 1/2. So if both you and your friend have an equally likely chance of scoring a point, that would indicate to us that yes, this is a fair game because each person has the same probability of scoring a point on an individual spin and therefore is equally likely to win the game. All right, let's look at another one. So same idea, this time our spinner is a little bit different. And the rules this time are the same. So if you spin an even number, you get a point. If your friend spins a prime number, they get a point. Okay, so first let's look at what are the even numbers. How many are there? So it's looking like for you, you can land on a 2, 4, 6, 8, or 10. So that's 5 numbers out of a total of 10. So your probability would be 5 out of 10 or 1/2. So half of the time you would expect to get a point. Okay, your friend, again, only gets a point if they land on a prime number. So we had said 1 was not prime, 2 was, 3 was prime, 4 is not, 5 is prime, 6 is not, 7 is prime, 8 is not because it's divisible by 2 and 4, 9 is not because it's divisible by 3, and 10 is not because it's divisible by 2 and 5. So we pretty much have the same 4 numbers that we had last time, 2, 3, 5, and 7, which means that's 4 out of 10 or only a 2/5 probability of getting a point. So is this a fair game? Well, you had 5 different favorable outcomes that would get you a point. Your friend only has 4 favorable outcomes. Therefore, this is not a fair game. You have a higher probability of scoring and therefore winning than your friend does. Okay, and one more for you to analyze on your own. You and a friend are playing a game where you roll a number cube. If you roll a number less than 4, you get a point. And if your friend rolls an odd number, they get a point. The person with the most points at the end of 10 turns wins. Okay, so I want you to analyze the number of outcomes or favorable outcomes for each person to get a point. So how many different numbers allow you to get a point? How many different numbers allow your friend to get a point? And then determine, is this fair or not? And please come to class ready with your explanations. All right, and before you go, to wrap up, please record something that you either learned or were reminded of, and then any questions that you have, and you should be writing down at least one thing for each prompt. All right, thanks for watching.